Okay, so this time we're going to talk about the three quantities, no? The density, the volume, and the gravity. Okay, so we're going to use these three quantities to compute the or determine the pressure of the particular fluid. Okay, so we understand that pressure is equal to force over area. All right, and then next is we're going to evaluate the units of these quantities first. So we understand that density, the unit of density is kilogram per cubic meter, and for volume is cubic meter, and for the gravity, that is meter per second squared. Okay, so how are we going to utilize these three quantities, no, to compute for the pressure? So we understand that force is equal to mass times acceleration, right? Which is mass, the unit of mass is kilogram, and the unit of acceleration is meter per second squared. And if we're going to multiply these two units, that will be Newton. Alright? Now, let us try to evaluate the three quantities, the density, volume, and gravity, if we can arrive with Newton. Okay? So if we're going to multiply the three, that will be kilogram per cubic meter times cubic meter times meter per second squared. And at this time, we can cancel out cubic meter. So the remaining units are kilogram times meter per second squared, and that is Newton, meaning force is also equal to density, volume, and gravity. Okay, so by looking at the units, no, so we can arrive with the same unit, Newton. All right, now let us try to integrate the density, the volume, and gravity into the equation of pressure. So that will be pressure is equal to rho, volume times the gravity over or divided by area. Okay, however, this is not the final form of the formula, because volume, okay, is actually equal to area times height. Okay, so we can rewrite the formula now into pressure equals density, area times height times gravity over area. So at this point, we can cancel out area here. So the remaining quantities will be density, height, and gravity. Okay, so this will be our formula or equation that we're going to use if we're going to determine the pressure, provided that what is given in the problem are the density, the volume, okay, and understood that if the experiment or the problem stated on Earth, okay, it is measured on Earth, So we can use gravity here, the magnitude of gravity, which is 9.8 meter per second squared. Okay? So, as a review, we just evaluated the units of density, the volume, and the gravity. If we are going to multiply the three, if it will arrive with Newton, the same with force equals mass times acceleration. Okay, since it shows that it arrives with Newton by evaluating the units, so we can use these three to determine the pressure of the particular fluid. However, the volume, we understand that it is equal to area times the height. That is why the area here at this point are cancelled out, and the remaining quantities are the density, the height, and the gravity. And if we're going to multiply these three, that is actually you are getting the pressure. Okay.